Welcome to this presentation on the organoleptic characterization of tropical goods using artificial vision and local binary patterns. This research was conducted by Ciordia Vázquez, Villagrán Villegas, Hernández Gómez, Rojas Hernández, and Hernández Márquez. Visual classification of good species is highly subjective and depends on the inspector's experience. Studies show only about 65% accuracy, highlighting the need for systematic training or automated approaches. Traditionally, experts classify goods through visual cues. Cabinet markers also rely on smell, touch, and even taste to distinguish species, which makes standardization a challenge in the field. This study focuses on the microtextural characteristics of 4 tropical goods from Veracruz, Mexico: mahogany, cedar, orijuelo, and purple rosewoods. Their anatomical traits impact both their aesthetics qualities and industrial application. We introduce local binary patterns, or LBP, as a non-destructive and efficient method for good characterization. Despite advances in artificial vision, distinguishing good species with similar structures remains a complex challenge. Our approach addresses this by focusing on fine microstructural details. Goods microstructure determines key features such as color, surface, gloss, grain orientation, and texture. These attributes not only influence visual appeal, but also affect mechanical behavior during processing. Mahogany features a yellowish sapwood and pale brown hardwood, with a medium to low luster and fine, uniform texture. Its grain varies from irregular to straight. The other goods, cedar, orijuelo, and purple rosewood, also present distinct variation in luster, grain, and texture, which contribute to their unique visual identities. This study focuses on 3 value tropical species: Swenia humilis, commonly known as mahogany; Enterolobium cyclocarpum, known as parota; and Cedrela dorata, or cedar. To evaluate these species, we developed a quantitative method using the local binary patterns descriptor. It analyzes structural variability and homogeneity, especially in high-value goods from Veracruz, Mexico. We calculate key textural metrics such as entropy, contrast, energy, variance, and homogeneity. These values help identify anatomical differences critical for selecting goods in high and furniture applications. The methodology of this research has 5 stages. First, sample selection. Second, image acquisition. Third, sample processing. 4, textural analysis. 5, binary patterns. High-resolution micrographs were captured with a digital electron microscopy in RGB format. The images were then converted to grayscale for accurate texture analysis. The methodology has 5 steps. The first, sample selection. Second, surface preparation. Third, image acquisition. Fourth, sample processing. And the last step, analysis workflow. A bright field ring-like system ensured uniform lighting during imaging, reducing shadows and reflection. This improves the reliability and consistency of texture extraction. Results. A bright field ring-like system ensured uniform lighting during imaging, reducing shadows and reflections. This improves the reliability and consistency of texture extraction. Conclusion. Successful characterization. In conclusion, the analysis of textural patterns using the local binary patterns operator effectively fulfills the objective of achieving accurate and distinct characterization of the studied tropical hardwood species. Industrial application. This approach has the potential to enhance the wood selection process in the furniture manufacturing industry in Veracruz and comparable tropical regions, contributing to higher material quality and production efficiency. Future research. The proposed methodology established a solid foundation for future research on wood characterization through advanced computer vision techniques and machine learning-based classification systems. Conclusion. Accurate characterization. In conclusion, the analysis of textural patterns using local binary patterns successfully fulfills the objective of delivering accurate and distinctive characterization of the studied precious hardwoods. Methodological advances. The developed methodology represents a significant advances in the non-destructive characterization of tropical woods through computer vision techniques. Digital images were acquired under standards electing to maintain image quality. These were processed to reveal the wood's unique textural patterns. Our method enhances species selection in tropical furniture manufacturing and sets the stage for future research using artificial intelligence and computer vision in sustainable forestry. In conclusion, the integration of artificial vision and local binary patterns has proven to be a reliable, non-destructive tool for the characterization of high-value tropical woods. This method not only enhances species identification, but also supports precision and sustainable wood selection for design and manufacturing. This is the reference of this research. We extend our sincerest gratitude to the institutions, technicians, and artisans whose collaboration made this research possible. Universidad Veracruzana, Instituto Politécnico Nacional and Tecnológico Nacional de México. Thank you for your attention.